internal structure. That is nucleus gracilis and nucleus cuneatus inside of these tubercles. Today we speak that pseudounipolar neuron in spinal ganglion gives axons to fasciculus gracilis and cuneatus. They goes upward and finish in this nucleus. And from nucleus gracilis and cuneatus start another fibers, and they goes to opposite side in medulla oblongata, and after that goes upward to the pons and midbrain and finish in thalamus. Name of this tract, well, number 11 nucleus gracilis, number 12 nucleus cuneatus, number 13 that is tractus bulba thalamicus, or another name is fibra arcuata interna, internal arcuate fibers. And these fibers makes decussation, decussatio lemniscorum, decussatio lemniscorum in medulla oblongata. Next, it is tractus spina thalamicus lateralis, number 15. Then spina thalamicus anterior, number 16. And it is the same, we have tractus rubra spinalis, tractus rubra spinalis, number 17. Then, in medulla we have nuclei of cranial nerves. Today you already said that ninth cranial nerve, glossopharyngeal nerve, then vagus nerve, number 10, and accessorius, all of them leaves medulla in sulcus posterolaterales. And 12th cranial nerve, 12th nerve, hypoglossal nerve, lives in sulcus anterolaterales. That is why nuclei of 9th, 10th, 11th, and 12th cranial nerves we have in medulla oblongata. Next, fascicles, fasciculus longitudinalis medialis. These fascicles participate in movement of the neck and eyes. For example, look, I fixed my eyes in my pen and then I move head with neck, but my eyes continue. These fascicles, fasciculus longitudinalis medialis, help to join together all of cranial nerves which participate in movements of the eyes and neck. Number, what is last number? 18. Number 18, fasciculus longitudinalis medialis. The same here it is, we have formatio reticularis, number 19, reticular formation, formatio reticularis. You remember tractus reticulus spinalis. It starts from nuclei of this reticular formation, participate in tone of muscles. Inside of oliva, we have nucleus olivaris. Nucleus olivaris, number 20. Number 20. Nucleus olivaris. This nucleus has communication with cerebellum. And inside of pyramids, we have pyramidal tracts. Number 21. Tractus corticospinalis lateralis, and this tract makes decussation. Number 21, tractus corticospinalis lateralis, and this decussation. Number 22, decussatio pyramidum. Another tract, tractus corticospinalis anterior. Anterior tract in medulla not goes to opposite side, but this tract, anterior tract, it continues into spinal cord. You remember here it is, and here it goes to opposite side in commissura alba anterior and finish in motor nuclei in anterior horn. Look here, this is motor nucleus in anterior horn, and this tract, anterior tract, corticospinalis anterior, it passes here it is, and then goes to opposite side in commissura alba anterior and finish in motor nucleus. That is why lateral tract it goes to opposite side where in
Pyramidal decussation.
pyramidal decussation in medulla.
Yeah.
And anterior tract, this tract, it also goes to opposite side where in commissura alba in spinal cord.
Yeah.
That is, both of these tracts, lateral and anterior, they goes to opposite side but in different places.
Yes.
Lateral in medulla and anterior tract in spinal cord.
Yeah.
And last, inferior peduncle of cerebellum. And here it is the same. We have some tracts, for example, here it is from nucleus gracilis and cuneatus. We have external arcuate fibers which goes to cerebellum. That is fibra arcuata externa. Bulbothalamic tract, that is internal fibers, and external fibers continues to cerebellum. Fibra arcuata externa number 23. Fibra arcuata externa goes to cerebellum. Then here was tractus
spinocerebellaris posterior.
No, anterior is the same.
Yeah.
And posterior tract, this tract, it goes upward and it passes through inferior peduncle
Yes.
and goes to cerebellum. That is number 24. 24. This is tractus spinocerebellaris posterior. Next tract, here it is 25. That is fibers between nucleus alveolaris and cerebellum. That is fibra alliva cerebellaris. And in opposite direction, cerebella alveolaris. They has two way in both ways. One between alliva and cerebellum, and between cerebellum and alliva descending tract. Fibra alliva cerebellaris and cerebella alveolaris. And also here it is, we have vestibular cerebellar tract, fibra vestibula cerebellaris and cerebella vestibularis. Also two-way connection between vestibular nuclei and cerebellum. Number 26. That is internal structure of medulla oblongata. Now some words about pons. Okay, this is medulla oblongata. Here it is pyramid, that is alliva, sulcus anterolaterales, and this is 12th cranial nerve, hypoglossal. Behind of alliva we have 3 cranial nerves, 9th,
Glossopharyngeal, vagus, and accessory nerve.
4, 12th, 11th, 10th, and 9th. This is pons. In ventral, normal position is this way. That is ventral surface, and here it is dorsal. In ventral surface, it is clear to see border between pons and medulla. And here it is, we can see 6 cranial nerve, that is abducens. Here it is 7th facial nerve, 8th vestibulocochlear nerve, and 5th trigeminal nerve here. That is 5th, 6th, 7th, and 8th cranial nerve leaves pons. And pons has inferiorly groove, that is sulcus basilaris, and superiorly, that is continuation of sulcus medianus posterior. Only 2 grooves, and this structure, that is medial peduncle of cerebellum, which continues to cerebellum, from pons to cerebellum. And now, okay, here it is dorsal surface of pons, this is ventral surface, and laterally here it is medial peduncle of cerebellum, here and here. Number 1, that is sulcus basilaris. Why it has so name? If you remember in previous semester, 2 vertebral arteries
Forms
basilar arteries.
joined together makes arteria basilaris, and arteria basilaris then subdivides into posterior cerebral, arteria cerebri posterior. Here it is internal carotid artery, arteria cerebri anterior, cerebri media, communicans posterior. Here is the same, cerebri anterior, cerebri media, communicans posterior, and arteria choroidea. Do you remember? We recycle. Here it is anterior communicating. Here it is two cerebellar, superior,
and
inferior anterior, inferior posterior cerebellar,
spinalis
anterior,
and
spinalis
spinalis
posterior,
posterior.
and arteria
Pontis.
pontis for pons. That is why this arteria basilaris it's present in sulcus
Sulcus
basilaris
basilaris.
on ventral surface of the pons.
Okay.
Sulcus medianus posterior and middle peduncle of cerebellum. That is all on external structures. Now, inside of pons, here it is trapezoid body, corpus trapezoidum, that is auditory fibers for auditory analyzer. That is number 4, trapezoid body. Laterally from trapezoid body we have nucleus, dorsal nucleus of trapezoid body, nucleus dorsalis, corporis trapezoidei. In ventral part we have pyramidal tracts here, pyramidal tracts number 5, cortica spinalis anterior, cortica spinalis lateralis, and cortica nuclearis the same. And near of pyramidal tracts we have gray matter, and gray matter of pons makes nuclei, nuclei pontis. And from brain cortex we have cortica pontina fibers, fibra cortica pontina. They goes to nuclei pontis, and from them tractus ponta cerebellaris goes to cerebellum. What is number 6? That is nuclei pontis. Number 7, tractus ponta cerebellaris, and this tract goes to opposite side. From this nucleus here, and from this nucleus goes here, and so on. From here and here it is. That is in ventral part. Now, in dorsal part, above of trapezoid body, we have lemniscus medialis. Lemniscus medialis. Number 8. Lemniscus medialis, bulbothalamic tract, tractus bulbothalamicus, continues into this lemniscus medialis. In your textbook, describes like this and this, both spinothalamic, anterior and lateral, the same participate in lemniscus medialis. I recommend you to draw another cycle here, number 9, and name of this place lemniscus spinalis. Lemniscus spinalis. It is near of lemniscus medialis. In your textbook, that is one place, both lemniscus medialis and lemniscus spinalis, that is describes together. But it is better, it is new information. Today we separate lemniscus medialis and lemniscus spinalis. Spinalis consists of spinothalamicus anterior and spinothalamicus lateralis. What else? Cranial nerves, we already said, 5th,
6th, 7th, and 8th.
5th, 6th, 7th, and 8th cranial nerves has nuclei here. And tractus rubrospinalis, number 10, and reticular formation, formatio reticularis, number 11, and fasciculus longitudinalis medialis, the same like here, number 12. Fasciculus longitudinalis medialis. These two diagrams, next time you need to draw some words about
Each.
cerebellum and fourth ventricle. Cerebellum and fourth ventricle. Well, first of all, cerebellum. Cerebellum. Cerebellum is above of medulla and above of pons, and it consists of two hemispheres, right and left, and between them, right and left hemisphere joined together with the helm of unpaired structure, that is vermis. Vermis joined right and left hemisphere. Hemisphere has superior and inferior surfaces, and maybe it is better, yes, I show you in preparate. Now here it is horizontal fissure, fissura horizontalis cerebelli, that is the border between superior and inferior surface. And on inferior surface we can see isolated small lobule. Look here, this is. This lobule is not far from medial peduncle of cerebellum, near of this medial peduncle. It has name flocculus. This flocculus send peduncle pedunculus flocculi. It goes to vermis, and this lobule in vermis has name nodulus. Nodulus in vermis, flocculus in inferior surface of hemisphere, and between them pedunculus flocculus, peduncle of flocculus. What else? Cerebellum consists of white matter inside and gray matter on the surface. And inside of white matter, if we cut cerebellum, inside of white matter, we will see nuclei of gray matter. Gray matter on the surface and gray matter inside of white matter. Is it clear?
Okay.
And this gray matter inside of cerebellum, they are nuclei of cerebellum. 4 nuclei you need to know: nucleus fascigii, nucleus globosus, nucleus embelliformis, and nucleus dentatus. Nucleus fascigii together with flocculus and together with nodulus, they make floccular nodular system, or it is absent in your textbook, this information. That is vestibular cerebellum. It's participate in balance of the human body. That is flocculus, nodulus, nucleus fascigii. It has communication with vestibular nuclei in brain stem through fibra vestibula cerebellaris and cerebella levaris, and participate in balance. Next part, that is spinal part of cerebellum, spinal cerebellum. It's also, this name is absent in your textbook, but it consists of another 2 nuclei: nucleus globosus, nucleus embelliformis, and vermis. And it participates in movements of the neck and trunk. And last, that is pontocerebellum, which pontocerebellum, it has communication with brain cortex, between brain cortex and cerebellum, and it includes both hemisphere and nucleus dentatus. And this part of cerebellum participates in movements of upper and lower extremity. Now, 3 peduncles we have in cerebellum, 3 peduncles. I already draw inferior peduncle, and all tracts you need to know in inferior peduncle. The same I draw medial peduncle. Here it is only one tract, pontocerebellar tract, tractus pontocerebellaris. And last peduncle, that is superior peduncle. It starts from midbrain and goes to cerebellum. And in superior peduncle we have 2 tracts. One of them is tractus spina cerebellaris, what? Anterior. And another tract from cerebellum goes to midbrain. And name of this tract is tractus cerebello tegmentalis. Tegmentum, that is part of midbrain. Tractus cerebella tegmentalis, between cerebellum and midbrain.
Okay.
And last, I remove cerebellum from here, and we can see dorsal surface of medulla and pons. And this dorsal surface, it's look like fossa, which has rhomboid shape. Rhomboid fossa, yes.
Yeah.
This rhomboid fossa on the floor of 4th ventricle, that is floor of the 4th ventricle.
Yes.
And above of this rhomboid fossa, we have roof of the 4th ventricle, and this roof has, no, it's look like tent. Look here. That is roof of the fourth ventricle. Floor, that is rhomboid fossa, that is floor, and above of rhomboid fossa we have roof of the fourth ventricle. And this roof has two parts, anterior part and posterior part. Anterior part consists of two superior peduncles of cerebellum, I already said, this, and the same in opposite side, superior peduncle. And I said, how many tracts in superior peduncle? Two. One that is spinocerebellaris anterior, another cerebella tegmentalis. That is one superior peduncle, here it is another superior peduncle, and between right and left superior peduncle we have white matter, which is closed space between both superior peduncles. That is velum medullare anterior medullary velum here. That is anterior part. Now, posterior part of the roof. Here it is two peduncles of flocculus, this peduncle, pedunculus flocculi. Here it is one peduncle of flocculus. Here it is another peduncle. And each peduncle of flocculus has it's joined with paired inferior velum medullare inferior. It is paired structure. This one and this one. Superior velum unpaired and inferior velum it is paired. And space between two halves of inferior velum, this space, closed with the help of choroid plexus, that is vessels, choroid plexus.
Plexus is found in fourth ventricle.
In fourth ventricle, and epithelium, which supply these vessels. Epithelium. And together epithelium, lamina choroidea epithelialis, together with vessels, makes telechoroidea. This telechoroidea, that is structure which produced what? Cerebrospinal fluid. Here in fourth ventricle, cerebrospinal fluid produced with the help of telechoroidea, and in telechoroidea we have unpaired opening, that is apertura mediana ventriculi quarti between two halves of inferior velum, and laterally two openings laterally, and one opening that is median, unpaired median opening, apertura mediana ventriculi quarti, that is fourth ventricle, median opening of the fourth ventricle and lateral openings of the fourth ventricle. That is how many openings? Three. 1, 2, 3. These three openings, that is place where cerebrospinal fluid from ventricles goes to subarachnoid space. If these openings closed, for example, in time of inflammation of meningitis, do you know?
Yes.
In time of inflammation, these openings, they can close, and in this case develops hydrocephalia. Fluid will accumulate in ventricles and it will expand brain, but skull bones not give possibility for brain to expand. That is why person die because high pressure of cerebrospinal fluid in ventricles, it's destroy brain. That is dangerous for human life. That is why these three openings are very important, because only here cerebrospinal fluid leaves brain and goes to subarachnoid space. Clear? Now what we can see in preparation.